And hello all, welcome to another day of mathematics learning. This is Mr. Callan here to help you with, how about this? Chapter 4, Lesson 1, we're calling it Represent Relationships. All right, goal today, I will represent relationships with words, with a table, with a graph, with an equation, different ways of representing the same thing. Now we have done this we've represented relationships with equations before, slope-intercept equations. We've also written equations in one variable. Goal is going to be, hey, if I give you a table, can you write an equation, or can you graph it, or can you write it in words? Eventually we will be comparing different relationships. That's like you got two people saving money, one's represented with a table, one's represented a graph. Okay, who saves faster? Who starts with more? But for today, let's just focus on one relationship. Now, we're going to do a cars activity, ladies and gents. You have an assignment that's going to be Lightning McQueen, Chick Hicks, and then one more page. Some of you have seen the Cars movie, some of you have not, and that's okay. Let's just go through it piece by piece. Lightning McQueen travels away from point A. You can call it Radiator Springs. He's traveling away from his town at a speed of 30 miles per hour. Now notice here, the words are given to us. Can we take these words and represent the same relationship graphically with points on a coordinate plane, with a table of values, and analyze it starting with writing an equation? Most students prefer to go with the table, so let's start with the table, shall we? Let's see here. Well, it doesn't say he started anywhere. If he's at point A, he's not gone anywhere, so let's just say point A, shall we? 0 miles after 1 hour, he's gone 30. If he drives another 30 miles in the next hour, that means he's now 60 miles away. Another 30 after that would be 90, and so on and so on. Nice part about watching videos, folks, you can always pause, rewind if you need to, pause, write down what you need to, and then come on back when you are ready. Now, most of my students in the past have preferred going from a table of values to its graph. If you want to, you can go to the equation. Just pause your video, come on back when you're ready to check out the graph. 0, 0 is going to be right smack on the number line. Then I'm going to zoom this in a little bit for 130 and 260. After 1 hour, he has driven 30 miles, not quite up to 50. After 2 hours, 60 miles is a little above 60, a little above 50. 3 hours is going to be 90. 4 hours is going to be 120, and so on. It would appear that there is a nice linear relationship with a constant rate of change. Pause if you need to. Come on back when you're ready. Let's go ahead now. We have this relationship represented in words, a graph of points, a table of values. How about an equation? Some people say a rule for the distance d, with t denoting the time in hours. So I'm looking here and I'm saying, okay, what do we start with? Does it increase or decrease? And how much does it increase? Well, very simply said, it goes up 30 miles every hour, 30 miles every hour. And oh, by the way, some of you will choose not to write the +0. You're welcome to if you wish. Your call. Onward we go. How far from point A is the car after? Now we want to know how far after 3 hours. Some of you will look on the table, although it can be a little hard to read, or excuse me, the graph can be a little hard to read, but the table is very clear. It says 3 hours, 90 miles. So lightning has traveled 90 miles after 3 hours. How about 16? Oh, Mr. Cowan. 16 goes off the table. 16 goes off the graph. Now, surely we could build a bigger graph. We could extend the table. On the other hand, don't be afraid to use that equation that we just created. If we know he drives 30 miles per hour and we now know he wants 16 hours, we could substitute in 16. And 30 times 16 is 480 miles. Mind you, you can add 0, but that doesn't change anything, right? We could have done the same thing for 3 hours if you had not noticed on the table. A simple 30 times 3, substitute in 3 hours, and you will find what d, distance, equals. How about 2.5? I'm looking here on the table. Well, 2.5 isn't necessarily on the table. Some of you have the number sense to see what's in the middle of 60 and 90. For the rest of us, you may substitute in 2.5. 30 times 2 is 60. A half of 30 is 15. So put those together. 30 times 2.5, 75 miles. How long will it take the car to travel 150 miles from point A? Oh, snap, here we are right on the table again. Took 5 hours. Now, you may use the equation, but in this case, it is the d distance that is known. Substitute 150 in for d and solve for t. If you divide both sides by 30, you'd still get 5. Let's go ahead and analyze a little deeper. What is the speed of the car and how is it represented on the table? Well, we know the speed is 30. And on the table, we see it goes up 30 miles for 1 hour and another 30 for the next hour and another 30 for the next hour. So that's really what we're going to say. We're going to say that d distance increases 30 as t goes up 1. What about the graph? How do we see that speed of 30 miles per hour on the graph? If we go up and we notice that over and over and over again, it goes up 30 miles for 1 hour, up 30 and right 1, up 30 and right 1. So that is how we see the speed on the graph. I'll even use the words rise and run. Lastly, symbolic rule. How did we see or write it or denote it in our equation? Well, you can write 30 times t. Yes, you may write 30 over 1 times t. After all, a rise of 30 miles every 1 hour times t hours. So 3 different ways of seeing the rate of change. Now here's something brand new, or at least we haven't talked about it yet in 8th grade, minimum values and maximum values. Now, frankly, I'm a pretty visual guy. I'm going to go ahead and look back at the graph. Is there a minimum amount, a smallest amount possible? Well, wait a second. It can't go beyond that point. In fact, I drew a ray and not a line. It cannot keep going because you can't drive for negative hours. That's nonsense. Therefore, it appears this is the lowest point possible at 0 miles. And so there is a minimum value. Is there a maximum? Well, technically, lightning could keep driving and driving and driving, 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 and driving. Now, not to get too existential with could he run out of space on the earth, but if we're measuring his distance and it could keep going up and up, there is no maximum value. So, ladies and gents, this is our initial relationship. We first were given lightning's, well, the relationship of lightning's miles to hours in words. We then were able to translate those words into a table of values, translate those table of values into a graph, and write it as an equation. We further analyzed that relationship, finding distance when we knew time, finding time when we knew distance, and how was the speed or rate of change represented in the table, 30 to 1, in the graph, up 30, right 1, and in symbolic form, 30 times t. Last but not least, we discussed minimums and maximums. So let's take what we learned with lightning and get into chick. Wait, there's no words here. There's no graph. There's no table. Ah, here we are. So in this particular case, chick Hicks is given to us with an equation. Now, at this point, I would recommend that you go ahead and pause the video, see how much you can fill. Can you take that equation and find a table of values, write in words what his relationship is, and write his distance? Now, just a note, chick cheats. Don't forget, chick's a cheater. All right, pause the video, come on back when you are ready. Now, before you jump straight to saying 0, 0, let me remind you that not every relationship is proportional, ladies and gentlemen. Take a look at his equation. It says, he says 75 plus 25. Let me go ahead and just substitute in 0 hours. Now, naturally, 25 times 0 is 0, plus 75 is, oh dang, chick cheats. He's already got a 75-mile head start. All right, what about if we tried 1 instead? 25 times 1 is 25. Order of operations says to multiply first, then add 75. 75 plus a single 25 is 100. Carry on with 2. 75 plus 2 25s, in other words, 75 plus 50 is 125. If you'd like, pause the video, fill out the rest of the table, come on back when you're ready to check your answer. All right, ladies and gents, now with the table in mind, I'm going to encourage you to go ahead and pause the video, go ahead and graph. Just note, please note, remember, Chick's a cheater. He's got a 75-mile-per-hour head start. It says so on our table, it says so on our equation, and it should show that with our graph. Chick starts at 75. Now go ahead, complete the rest of the table, pause your video, come on back when you're ready. And so, ladies and gents, now we have a fine-looking graph. Appears to be a linear relationship. And many folks at this point in the past, my students have liked to say, hey, Mr. Cowan, let's talk words real quick. I can tell you what's going on. Chick Hicks cheated, so he already starts. Chick starts 75 miles away. And what happens? And his distance from point, I guess it's distance from point A. Again, maybe that's his town, maybe that's Radiator Springs. And I'm going to leave some blanks here, and I would encourage you to fill in those blanks. Now I'm going to write here in red, he did start 75 miles away. And then in green, I'm going to say, okay, his distance increases. How much does it increase? How much is he driving further? Well, 25. Okay, 25 what? We are comparing miles to hours, 25 miles per hour. All right, ladies and gents, we now have represented the same relationship in words, in a graph, in table, in equation form. So let's just analyze a little further and call it a day. Analysis, how far from point A is the car after 3 hours? So I can see it pretty clearly on the table, or on the graph, 3 hours, 150. I can also see it on the table. Nope, excuse me. 3 hours, Mr. Cowan, focus. 3 hours, 150 miles. So after 3 hours, he is 150 miles away. How about 16? Yikes. 16 is way off the table. I suppose I could continue, or I could make a bigger graph, but there's got to be a better way. Oh, yeah. We talked about this previously. We could simply use the equation. And now we know what the time is. We'd like 16. So 25 times 16, 400, plus 75, 475. 2.5. Many of you will go back directly to the equation. Some of you with the right number sense will say, well, wait a second, I think I know what's right in between 125 and 150, and that would be 137.5 miles. Don't believe it? Check it. Multiply 25 by 2.5, then add 75, and you'll get the same thing. Now, guess what? For number 3, we've already done it. This time we were given the distance, 150 miles, 3 hours. Yep, we already answered that part of the question. Okay, so how is it shown in table form? Let me get to my color wheel here. I believe I used purple the last time. So how do we see on the table what his speed is? Well, it appears that he goes up 20 miles for every 1 hour. There's another 25 miles for another hour, and it would continue on and on. D increases 25 as t, time, passes or goes on or increases 1. All right, what about the graph? Well, if I recall, going back up here to that nice little graph, it does appear that it goes up 25 every 1 to the right, and 25 and 1 to the right, up 25, right 1. So let's go ahead and say that, shall we? Up 25, and right a positive 1. Last but not least, let's talk about how did we do it with symbolic rule? Well, in fact, we saw it right here in our equation, 25 miles for every t hour. Now you can write the dot if you wish. You could also write 25 to 1 as a ratio multiplied by t. All right, let's wrap up with some of the newer ideas for this lesson. Is there a minimum and is there a maximum? So if we once again analyze Chick's data points and we follow behind, is there any number that it cannot, well, he's a cheater, remember? So it does not go beyond 75 miles. That is his minimum value. Some of you will write as an ordered pair. Maximum, once again, there is no maximum. And so we've represented Chick's relationship of his distance to his time in words, in graph form, as a table of values, and as an equation. We further dug a little deeper. Using those representations, we were able to find a distance if we're given a time. We're able to find a time when given a distance. Everything in life has advantages and disadvantages. Sometimes the graph and table, boom, you can catch it like that. Other times the equation is really going to be the most help. And minimums and maximums is where we're headed for today. Now, folks, one more page is all I'm asking of you today. One more page, and that is the king. We will save Doc Hudson for the next day, although if you want to give it a try, you'll notice that Doc actually gave you the graph. But your assignment for the remainder of today is to finish up the king, represent his relationship in words, in graph, in a table. Oh, they gave you the table, and in an equation, and then analyze a little further. Come back for tomorrow for answers. That's what I got, folks. Take care, do well, and let's grow.